Alright, for etching, you should find everything you need in the hood. A watch glass. You'll pour a little bit of the 2% nitric acid and ethanol into the watch glass. Recap it so it doesn't spill. You will hold your sample in tongs, and I usually hold mine vertical like this. I will time 1 minute of etching for this particular steel with nidal. It's about 1 minute. Other etches take less and more time, and you have to sometimes experiment with the time to know exactly how to get a good etch. So what I'm going to do is I'm going to swab the acid with the wand, the cotton tip applicators, and I'm going to rub it onto the sample and let it drip off. That's why I'm holding it vertical for 1 minute. Now my beautiful mirror is being etched by this acid, and it'll lose its mirror finish and start to look dull again. So when the time is up, you then rinse the acid off into this waste beaker with ethanol and dry with air. The applicator is thrown away in the solid waste and the acid into the liquid waste. Now let's go to the microscope and see what it looks like. In order to view the micrograph of your sample, we move to the Olympus microscopes. There are 2 in the lab, one next to the polishing station and one in the back of the room by the hardness machine. First thing you need to do is press your sample, which happens right here. Here is my sample and a glass slide with some putty. This putty will flatten out my sample. I put it on this press, put my sample on. You might want to pay attention to how you're orienting your sample. Use a Kim wipe so you don't scratch your surface, and press down. This should create a flat sample for the microscope. This book you'll find over by the microscope goes through every metal and what the procedures are for grinding, polishing, and etching those metals. It's a good handbook. Here is the Olympus microscope, and you should have a manual with written instructions and the passwords written in here for the various microscopes. The power is turned on with 2 buttons. The light source, halogen light source, is here. And I have it on a timer, so you want to hit start on the timer to turn the light on. Your sample is placed on this stage. You pull back this spring-loaded arm that'll hold it in place. There should be no lens when you're bringing samples in and out. And you can move the stage down with these knobs. And then move your lens into place. This controls your stage X and Y. You will see a light on your sample. Move it over top of the metal. With your lens in place, we follow the same procedures as with the old microscopes. We turn the focus knob, moving the sample towards the lens while watching the sample and lens. Then we look through the eyepiece and turn the focus knob towards yourself to find the focus. Okay, so now looking in the eyepiece, I turn the large focus knob toward me and find the focus in the camera. Once you have the sample in focus, there is a lock here on the left side. You pull that up, and that lock will serve to protect the objectives from any damage. As you move the lens objectives around, you can see they get quite close to the sample. However, if you have locked this at 5x focus, you wouldn't have to worry about scratching the lens or the objective lens at 50x focus. Once you have the password in the computer, this is the desktop, and your software here, LC Micro. Once the software has opened, you get this screen and you choose Live View over here on the right toolbar. We start our observations at objective 5x and use the gross focus to get it in focus and then lock the objective lens. You then can find your fine focus with the inner knob shown here. So you'll turn this, which is the fine focus, until you get a good focus on the computer or in the eyepiece. The image actually looks better in the eyepiece, and so you want to be sure and look in there, although you'll take a photograph with the software. Once you have this focused at 5x, once you have a focus at 5x, you rotate to the 10x objective using this wheel, and when in place you'll hear a click. You then go to the fine focus and focus your image with the fine focus. Now I'm ready for 20x, so I rotate the objectives, click, fine focus, and focus my image. The objective, if the objective is to count grains, as it is in 202, you want about 100 grains in the field of view. So you want to count about 10 grains across. We have about twice that much. So that's telling me I need to go to one higher focus, 50x. Turning to 50x. Focus. Now the number of grains is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is a little more than 10 or 100 in the field. However, this is the highest magnification I have on this microscope. So it will have to do for counting the number of grain boundaries. The sample in this video is a little dark and actually may be a little over etched. If you have over etched your sample, you just go back, polish again, and re-etch. Over here on the right, I have it selected at automatic focus, but you can go to manual and lighten it up by hitting the plus button. Okay, if you're ready to take a photograph of your sample, you choose up here your magnification for the photograph, 50x. This will change your toolbar down here. Take a photograph. You see the toolbar is now 20 micrometers. And save as. You can create a folder on the desktop for your images. And you want to name the image according to its characteristics, such as 20% rolled, face. Okay, and then you go back to live to move on to your next image. When you have all the photographs you want of your sample, you rotate the objective lenses to no lens in order to move the sample in or out, and you want to unlock the focus on the right. When you are finished for the day, you can turn the light source off. Of course, it's on a timer and will go off after some time. But if you remember, please turn it off. This timer is in case you forget. The computer you can leave on. It will go to sleep automatically.